Hi, everybody. I am sick. My daughter is very sick. Everybody is sick. But that doesn't mean you can't program. It's a very exciting day. You're going to do phase 1 of step counting, which is getting a baseline solution that is not very good, so that way we can all use our own creative ideas to improve upon it. This is what's due by Wednesday. I just wanted to put this on slide 1, just so you're right there and you know. So we're going to read the data, parse the data, plot the data. I have a suggestion about what this baseline algorithm is going to be, and you should do it. And then it's going to be helpful to visualize where we think steps are happening in the data. So this is what it's going to look like, hopefully at the end of today, or possibly at the end of Wednesday. You'll see some data, and each of these circles is where we think a step is happening. And you might be thinking, well, gosh, probably some of these aren't really steps. And you're right, they probably aren't. That's why the baseline is not a good algorithm. So in 5 minutes or less, I want to get you up to speed. Remember that our data looks like this. You've had a lot of experience sucking in a huge file as a giant string and then breaking it into lines and doing things. So that's what you're going to do. The first number in every row is the accelerometer x value, and the second number in every row is the accelerometer y value, and so on. And so we need a way of creating a list of each second number in every single row. And there is no easy way to just extract an entire column like this. It's not a 2D array. So you're going to have to loop over each row one at a time and get out a particular number to add to a list. I think this is what your code should look like. So in the documents that I've provided, I gave you the read file method, same one. So read a file, and then you're going to split it on new line characters, and then you're going to create your own get column as list method. So this second line here where it says acceleration y, and you give it a column number 1, what it's going to do is it's going to loop through every single line of this file, and it's going to access index 1, which would be the second number. And so you're going to create an array list of all of those second numbers, which are the y accelerations. Once you've got that, I have written my own plotting tool, and this code shows you how to use it, but it's actually, I explain it in more detail in the document. And what that'll let you do is display your data like this. You have too much data to display in an easy to see way. So if you click and drag, you can get a zoom window that will let you zoom in closer to see what's happening. So if we were here in person, this is what I would say to you. I would say, if this is acceleration data for the x, y, and z axes, how many steps do you think are here? And then you would talk with your neighbors, and you would say, and you say, okay, I see it. I think that maybe each of these peaks in the acceleration data corresponds to a step. And that is exactly our baseline algorithm. Good job, everybody. Except, hold the phone. Imagine, close your eyes, imagine the phone on my hip, and I'm taking steps. Think about when the acceleration is the fastest. It's each time I swing that left foot. But how many steps am I taking for each time I swing my left foot? If you said 2, that is correct. If you are still thinking, what's he talking about? Stop. Imagine taking the steps. So probably we want to multiply the number by 2 for however many peaks we're detecting. But another thing I'm noticing is, some of the peaks are quite pronounced, and then like in the blue data here, they're kind of less pronounced, and there are arguably maybe more of them. So how do you decide which axis to choose? The answer is all of them. So for our baseline algorithm, the phone is oriented in space, not in alignment with any particular axis. That's why you see accelerations in all the axes. So what we're going to do is we're going to combine all 3 together to get an overall acceleration. So here's a little illustration. So you can see the y-axis, the x-axis, and the z-axis. If I move my phone kind of diagonally this direction, all we want to know is, what was the strength of that acceleration in the direction it was actually moved in? We don't want to know what was the strength of the acceleration in just one direction only. So the way you do that is with this kind of modified distance formula. X will be your x acceleration, y is the y acceleration, z is the z acceleration. If you square each one, add them together and take the square root, that's the magnitude of this vector. And if that's freaking you out, all that means is it's telling you the strength of the acceleration overall in whatever direction it's going in. So that'll be the second step of your algorithm. And then the third step is we've got to find peaks. Let's assume where the 2 arrows are, those are peaks in the data. If we were in person, I would say, turn to your neighbor and tell them, how do you know they're peaks? What are you going to look for? And you would probably hem and haw, and then you would say, aha, where the arrow is, this number is larger than the values on either side. So if you imagine these are heights in the graph, here I've got a height of 35, and then I go all the way up to 69, and then all the way back down again to 67. So that would correspond to a little tiny peak. So that's what you're going to have to do. Once you have your array list of magnitudes, you're going to loop over pairs of 3, and you're going to count how many times do you see one that's larger than the neighboring 2. And we'll do that next time, and then I also have some guidance for how you can actually put dots at the location of every peak, because it will be helpful for us to actually see that to visualize. All right. As usual, you can get the links in the Schoology assignment, or the Master Resources document, or straight from these slides. Lots of places. They are all due pretty soon here, so you don't have time to spend a whole day not doing things. And there's a lot more detail in these links that will guide you. The TAs are also there. They're so helpful. You know this. Okay, good luck, everybody. This is my recommended timings. You got this.